Okay, gonna start some LeetCode for today. These are questions that I've solved before. I'm just running through some of the easy ones. I'm not gonna do any, maybe I'll do some studying after this one, but I wanna get one LeetCode video today. So I'll just do this easy one, and it's near the top. It's actually the topmost one that I can complete right now. So let me make this so you guys can see it. Given a non-empty array of integers, every element appears twice except for one. Find that single one. Your algorithm should have a linear runtime complexity. Could you implement it without using memory? So, interesting. I don't know if I solved this one recently, actually. So, I could do it with memory. It's probably a good thing to start in an interview is, you just use like a hash table or like a dictionary where you have like codes and stuff, and then you could keep stats of things, basically. So you could keep track of what you've seen. That's interesting, though. Could I implement it without using extra memory? I could brute force it. Yeah, without using extra memory, but can I do it with a linear runtime and no extra memory? That's the question. And I can't think of a way to do it without extra memory without brute forcing it. So I'm going to do it the efficient way with data, and then I'll see what I can do afterwards. So we'll just set up a little dictionary here, and then for I set up a for loop to go through all the numbers. If just checking if we've seen the number before. Otherwise, we have seen the number before. And then it's add one to it. So after that, we go and we'll loop through all the keys, and if that should be it, right? I think this should work. Pretty sure. There might be something I'm missing. Okay. What about this test case? This is a really easy one. Helps to have solved things like this in the past. Okay, apparently it works, so I'm going to submit. Look at that one. Yikers. I must have brute forced it back 8 months ago. Oh, look, I haven't solved this one recently. Nice. It's pretty fast, so that's good. The memory, though. So, yeah, let's do it without using... let's do it without using data now. I'll brute force it. It'll be fun. So this is O of n runtime, running through it once, and then we should have less keys than numbers. So it's O of n with the space complexity of n, because we're going to get, it's a little bit less than n, but yeah, n, I guess. We're using space. It's not constant. Okay. Going back, we don't have this. Okay. So we're going to run through it again. This is the brute force method. guess it could be I plus 1. This is j. I guess we always want to start at I plus 1. So if nums at j equals nums at I. Wait, is there a brute force method? Ooh, actually, I don't know if I could do this brute force because I need, like, I would need a variable here or like that. Yeah, so I would still be using data. Interesting. Maybe I'll need 2 pointers then. Yeah, that's what I need. Okay. Which I think is fine. Yeah. We have a solution here. All right, I'll write it out, I guess. So we'll have right. Then we have I really could initialize these in here, but whatever. Okay. Yeah, we want it to be greater than, because when it's equal to, that means we're at the same spot, which is obviously going to be a duplicate. Okay, so how about we do this? If right equals left, and this will be like our return true, or return the number. So if right equals left and nums at right doesn't equal nums at left. Does that work? Yeah. If nums right equals nums left, we want to have a minus minus here just so we don't infinite loop. We will return, I don't know, just that one. Otherwise, if nums at right equals nums at left, we will break. Left plus plus, we need to reinitialize right. Brute force, there we go. So this should always hit, I think. It's gonna be slow though. Undefined, nice. Okay. Let's see here. So iterating through. Why am I getting a? Because it might never do this. That's why. Let me think here. So for the 4, it would start left here, right is here. It would keep going until it hit here. This should work right away. I'm confused. Because it should keep going. Because left is 0. So right is 4, 3, 2, 1, 0. I don't know why this isn't working. Interesting. I'll space that out. Debugging live. Let's see what output we get. This is stupid. What? 4. Right. Oh, it's if it equals. Duh. That's what we wanted. Whoopsies. Alright, this should work now. I think. Okay, there's one answer. I don't know. Let's submit. Two. Oh. So we need... Interesting. This is tough. Okay, so I have everything working, but I ignore like the left side of the array. So I could just look up the solution, but I want to run through this at least with some sort of a crappy brute force method. Yeah, of course it worked with there. That was a stupid submission. Anyways, Let me think. I have to think about this. So I need to continue using the left side. This doesn't work, so I'll have to keep using the left side, I guess. Or it doesn't say I can't manipulate the array that's given. Okay, I have an idea. Here's what I'm gonna do. This is going to be interesting. Okay, so we're going to erase most of this. We're going to manipulate this. We're going to erase everything except for the one that has 1 in it. So here we go. So instead of breaking, I want to... I don't remember if this works. I think we want the right first, because that won't affect the left. Let's see what happens. This is going to be ridiculous, I think. Okay. It's happening. It's happening. Dude, this might work. Insane. Wonder how slow it is. What? My output is 3. Okay, I'll need to check what nums is. I'm getting so close. So basically what I'm doing is anytime I see a duplicate, I just delete both duplicates until there's only one left. That's my plan. So, yeah. Also, need a semicolon there. Alright, so that's our test case here that's fucking up. So we'll put that there. run this code and then just look at the console to get an idea of what's happening. Okay. Okay, I think I know what I need to do. So when we delete everything here, I should reset these. Yeah, because this needs to go back to 0 because we deleted the first one. All right, so I'm trying to think, because it's just going to go up by 1. So this is working properly, actually, so that's good. But if we delete in the front, why don't I do that? Wow, the skills. And then I could do that because it minus minuses. And then I can break here. Watch this work. That'd be sweet. Okay, I'm submitting this. Pog. Okay. Wow, what a hack right there. All right, we're looking at the solution now. List operation. Iterate over all the elements in nums. If some number in nums is new to array, append it. If some number is already in the array, remove it. Okay. Interesting. Hash table. This is the one I came up with. Okay, great. O of n, O of n. Yep. Approach 3 is math. What? Using math? Oh, you can't see. Hold on. 2 times a plus b plus c minus a plus a. Oh. Wow. That's okay. That's going to be like too specific to remember. Bit manipulation. If we take the exclusive OR of 0 and some bit, it will return that bit. If we take the exclusive OR of 2 of the same bits, it will return 0. So the exclusive OR of A and B and A will return B. So we can exclusive OR all bits together to find the unique number. So how do you exclusive OR in JavaScript? Hold on. XOR in JavaScript. Is it math.xor or something? So what's XOR? Set each bit to 1 if it's a caret. Bitwise AND, bitwise OR, bitwise XOR. Okay. I need an example of this. Hold on. What I think to do this though, maybe. Let's see here. How do they do this? A equals 0. What? for I in numbers. So it goes through everything, sets it to 0. Oh, okay. So it keeps exclusive ORing on top of each other. Okay, so hold on. Let me try and write this out. Okay, I think I get it. So it's just a caret. All right. So we have, let me just get all this. Okay. God. So, start it with this, and then for let I equal 0, I is less than nums.length, I plus plus. So XOR equals XOR is that really it? That's really it. Okay. My runtime is 104 milliseconds. I'm gonna submit it and see what happens. 56:35. Look at that. So good. But I just went to the solution and looked at it. So okay. I kind of like this because I have all 3 of my solutions in here. Just this like crappy brute force thing that was more difficult than just setting up a hash table. All right, so there you go. That is single number. Took me 20 minutes. Fun. But that's like one of the easiest problems on here. It took me like a minute to solve it, but then to do this without extra memory and linear is insane. But this is that discrete math that I should know. But when do you ever use this in real life? That's what I'm wondering. Very specific cases where you need to be super efficient. But okay, now I'm a little bit more aware of it. So there you go. There's one problem. On to the next.